In our project on structural bamboo products, we're looking at the idea of using bamboo in an analogous way to the way people use wood products for construction. So for instance, for wood products, people take wood and they cut it into various shaped pieces, and they produce things like plywood and oriented strand board and glue laminated timbers. And the idea is that we'd like to do something similar with bamboo. So there's several interesting things about bamboo as a material. One is that it grows very fast, and if you take an acre of land, for instance, people have shown you can actually grow more mass of bamboo than you can of wood. It's a renewable resource, but another interesting thing is it actually has extremely good mechanical properties. If you compare the mechanical properties of bamboo with typical woods used in structural engineering, it's got very comparable stiffness and strength. For the same density, the stiffness is a little bit lower and the strength is a little bit higher in bamboo as compared to wood. So this is a bamboo culm. This is a Moso bamboo culm, where we're actually working on Moso bamboo. It grows in China. And one of the things we're interested in is how the density varies from the inside to the outside of the culm wall. So if you took a little piece of bamboo from the inside here, the density would be lower than on the outside over here, and the mechanical properties also vary radially across this thickness here. So the mechanical properties tend to be a little lower on the inside and higher on the outside. And so one of the things we're interested in doing is trying to see how you might optimize the use of the pieces of the bamboo in the structural bamboo product in order to get the most sort of bang for your buck, to get the best properties you can with the material that you've got. So this is one of the samples of bamboo that we test, and you can see it's a fairly thin sample. So one of the things we do is if this is the whole wall of the culm, we take specimens from different radial positions, and then we do bending tests on these beams. So we set it up like this, and we do a little bending test like this, and that gives us a measure of the stiffness of the bamboo and also the bending strength of the bamboo. We also do compression tests as well, and we look at various other kinds of mechanical behavior. We look at shear and fracture as well. So we're hoping that in the end, this material might be more widely adopted, especially in developing countries that have a lot of bamboo resources, and that show that you could use them in construction in a way analogous to wood products.